Welcome students. We have already started a new chapter, that is transport in plants. We have seen the introduction, that is how transportation will be done in plants. Here we have two types of transport based on the distance, that is long distance transport and short distance transport. If the transport of water is for a long distance, then it is called as long distance transport, which is done by vascular tissues, that is xylem and phloem. If the transport is for a shorter distance, then it is called as short distance transport. We have those examples: diffusion, osmosis. These are the examples of this short distance transport. Here we have also seen means of transport, that is transport is passive as well as active. In passive transport, we don't need to spend energy. It is done when there is difference of concentration. When there is difference of concentration, then transportation will be done without any expenditure of energy. That is passive transport. And in active transport, energy needs to be spent. Energy needs to be spent in active transport. So without energy, transport cannot be done, and active transport can be against concentration gradient. In this class, we will discuss various passive process. We will see passive process, passive which does not require the energy, only there should be difference in the concentration, then the transportation will be done. So we will start with the passive processes, and in that first we will be seeing about diffusion. We have already known what is diffusion. We have studied this diffusion in our previous classes, 9th and 10th class. We have studied what is diffusion. So diffusion is transfer of solute particles, from higher concentration, that is transfer of solute particles. Remember this one, transfer of which particles? Solute particles from high concentration to low concentration. Transfer of solute particles from high concentration to low concentration. And till when this transfer will take place? Till at both the sides the concentration should be equal. Till the concentration is equal at both the sides, till then the transfer will take place. Once the concentration becomes equal at both the sides, then the transfer will stop. For example, you just take a beaker. Here 80 molecules are there. Here only 10, or here no molecules are there. So transfer will be taking place from here till here. This is high concentration and this is low concentration. So transfer of solute particles from high concentration to low concentration. So from here 80, so till 40, till it becomes 40 here and 40 here. Till then the transfer will takes place. But as soon as this side gets 40, here also 40, then the concentration is equal. The concentration becomes equal. So then there is no transfer. So the transfer of molecules, transfer of solute particles or solute molecules from a region of high concentration to a region of low concentration, till the concentration becomes equal. Till the concentration becomes equal. This is also important. Here 4 things: transfer of solute particles. Then from where to where? From high concentration to low concentration. Transfer of solute particles from high concentration to low concentration, and this transfer takes place till concentration becomes equal at both the sides. So that process is called as diffusion. That process is called as diffusion. So, diffusion is a passive process. Diffusion is a passive process, that is, it does not require energy. It does not require energy. So, no ATP is required. ATP is a molecule, energy rich molecule. ATP is a energy rich molecule. So, when there is no need of energy, then there is no need of ATP. ATP is not required. Because energy is not required, then the energy giving molecule is also not required. As diffusion is a passive process, it does not require energy. So, when it does not require energy, there is no need of ATP, no usage of ATP. ATP is not utilized during diffusion. The only thing which need is there should be difference in the concentration. No ATP, but there should be difference in concentration. So, if the concentration becomes equal, that is 50-50 at both the sides. So, this transfer of substances, solute particles from high concentration to low concentration till it becomes equal without ATP, till it becomes equal without ATP. So, that is diffusion. So, diffusion is a process in which solute particles are moved from higher concentration to lower concentration till it becomes equal. Now, let us see what are the different factors which are affecting the rate of diffusion. Factors affecting the rate of diffusion. Here first is temperature. The first factor which affects the rate of diffusion is temperature. If the temperature is higher, that is, with the increase in temperature, the rate of diffusion will be faster. That is, temperature and rate of diffusion both are directly proportional to each other. Both are directly proportional to each other. If the temperature increases, then the rate of diffusion will also be increased. If temperature is increased, the rate of diffusion will be increased. Example here we take is when the food is hot. When the food is hot, the smell reaches to a larger distance. The smell reaches to a larger distance. When something is being cooked in our neighbor's house, when we will be sitting in our homes also, we will be able to smell. We will be able to smell it. We will be telling, something is cooking in the neighbor's house. Something delicious is cooking in neighbor's house. Or if it gets burnt, we will be able to smell it. Something is burning in the neighbor's house or something is somewhere. So, here what happens is when the food is hot, the diffusion, that is transfer of molecules, transfer of that molecule, solute particles, that is whatever is there in the utensil, when it is heated, that solute particles will be transferred in the air to a larger distance. It will be transferred to a larger distance when the temperature is high. But you just open a refrigerator, their temperature is low. When you open refrigerator, will you be able to smell the things which are present inside it? No. But when you heat it, you will be able to smell it. So, with the temperature, the diffusion, because that smell is because of the diffusion of that molecules. The smell is because of the diffusion of molecules, movement of molecules from utensil to outside. Okay. So, if the temperature is more, then the rate of diffusion will be for a faster and for longer distance. It will be faster and it will be for longer distance. The molecules will be traveled to a longer distance. Why they will be transferred to longer distance? Because when the food is heated, When the food is heated, the food gets heat energy, and that heat energy is converted to, that is when food is heated, that means heat energy is given to the food. So now what happens is that heat energy will be converted to kinetic energy. The heat energy will be converted to kinetic energy when the food particles get the heat. So what happens is the food particles will get the kinetic energy and they will start to move to a longer distance. So the thing is, with the increase in the temperature, the rate of diffusion will be faster and to a longer distance. The next factor which affects this rate of diffusion is density of the substance getting diffused. Density of the substance getting diffused. The heavier the substance, then it will not be able to travel to a faster distance. It will not be able to travel at faster rate and to a larger. It won't be able to travel faster and to a long distance. So if the density, according to Graham's law, here rate of diffusion, according to Graham's law, density is inversely proportional to the root of the substance getting diffused. So if the substance which is getting diffused is heavier, if the density of the substance which is getting diffused, if it is heavier, then the rate of diffusion will be slower. The rate of diffusion will be slower. If the particle which is getting diffused is heavier, then the rate of diffusion will be slower. If the particle is lighter in weight, if the density is less, then it will travel to a larger distance. It will travel to a larger distance. So now the next factor which affects the rate of diffusion is concentration gradient. Concentration gradient. For example, here in this beaker, here beaker is filled with water. Beaker is filled with water. Now here we have KMNO4 crystals. At the corner we have KMNO4 crystals. So here it is nothing. There is no KMNO4 molecules. Only it is present here at the corner. Here what happens is, here if the concentration here is more, then here the rate of diffusion will be faster. The rate of diffusion will be faster. If this is more, if the concentration of the solute is more, then the rate of diffusion will also be faster. So more concentration gradient, the faster will be the rate of diffusion. If the concentration gradient is less, then the rate of diffusion will also be less. Another factor which affects the rate of diffusion is surface area. Here the surface area. If the area is more, the diffusion will be more. If the area is more, the diffusion will be faster and it will reaches greater distance. If the surface area is more, the rate of diffusion will also be faster. We can take the example of lungs here. Our lungs, when it expands, the movement of molecules, that is air, will be going inside more. The air particles will go inside more. But when the rib cage contracts, what happens? The surface area will be reduced and the number of air, that is molecules which will be going inside, will be less. So here if the surface area is more, then the rate of diffusion will be more, that is more particles will be diffused. And if the area is less, then the rate of diffusion will also be less. Next and the last one is lipid solubility. The rate of diffusion also depends on lipid solubility, that is fat soluble. If the substance is non-polar or fat soluble, then the rate of diffusion is faster. If the substance is lipid soluble, that is fat soluble, then the rate of diffusion will be faster. So these are the various factors which affects the rate of diffusion. The first is temperature. More temperature, faster will be the rate of diffusion. Next is density. If the density is more, then the rate of diffusion will be less. Here concentration gradient. If the concentration gradient is more, then the rate of diffusion will also be more. If the surface area is more, then the rate of diffusion will also be faster and more. And if the lipid solubility, if the solute particles are non-polar, then the rate of diffusion will be faster. So with this we have finished diffusion. Here diffusion is a process in which transfer of solute particles takes place from high concentration to low concentration till it becomes equal without expenditure of energy. No ATP is required. This diffusion depends on temperature, it depends on density of the substance, it depends on concentration gradient, it depends on surface area, and lastly it depends on lipid solubility. These are the 5 factors on which the rate of diffusion depends. In the next class, we will take up facilitated diffusion.